Okay, here we go with hints for homework sheet number 11. First question, we've got a function f of x equals 2/5 of x minus 1. And we are asked to find f to the negative 1 of x. Now that's the inverse function. Okay, so how do we find the inverse function? The first thing we do is we say let y equal 2/5 x minus 1. And then once you've done that, the next thing we need to do is we need to change the subject. And what do we change the subject to? We change the subject to x. So I've got to turn this formula here into x equals. So how am I going to do that? First thing is get the negative 1 over to this side, then get the 5 over to this side, then get the 2 over to this side, and eventually I'll have x equals. And remember, your final answer is written as the inverse function of x is, and we turn this formula here into x's. Question 2. This one says the gradient of a curve is given by the formula dy by dx equals. So the first thing I need to do here is take the 3x bracket 2x minus 1 and remove the brackets on that. Give me 6x squared minus 3x. Then I need to find the curve. So this is going from dy by dx back to y, so that's an integration question. So if I can integrate the function, and remember your plus c at the end, we're also told in the question that it passes through the point negative 110. So if I substitute the negative 110 back into this new formula, that'll let me work out what c actually is, and then I can get my full answer. Find the stationary points. Now remember, the procedure for stationary points is the first thing we need to do is differentiate, because that gives us the gradient formula. Then we need to put the differentiated formula, the dy by dx equal to 0, because that tells us all the places where the gradient is 0. In other words, where the graph goes flat. How do we do that? We do that by solving the equation. How do we solve the equation? By factorising. Right, these are all the wee steps that should be going through your head for these questions. So once we've differentiated, once we've put it equal to 0, once we've solved by factorising, we're going to end up with x equals and x equals. Next stage is to work out what the y points are. How do I work out the y points? I put the x numbers back into the y formula. Once I've done that, the last and final stage is to do my little nature table. Remember, as you get closer to the x number, between the x numbers, after the x numbers, we're looking to see how the graph actually looks. Does it look like that? Does it look like that? What does it actually look like? Okay, how do we going to find that? We put these x numbers that you've picked here, this one you've found, this one you've picked, this one you've found, this one you've picked, we put these into the dy by dx formula. So that'll tell you the shape of the graph in here. Once you've got the shape, you can write down whether it's a maximum, whether it's a minimum, or whether it's a point of inflection. Question 4. This is a long question, guys. So how do you find the equation of a tangent? Well, what is a tangent? A tangent is a straight line. Again, the process your brain should be going through. What do you need for a straight line? You need an AB, and you need a gradient. What does the question give us? The question gives us a curve. So we've got a y formula, y equals blah blah blah, and we're told that it passes through x equals 1. So good news is we've got at least part of this part at the top here, because we know the x coordinate's 1. If we know the x coordinate, then the second one is the y coordinate. So if I just substitute the 1 not straight into where the y is, but if I put it where all the x's are in this formula, then that's going to give you the y number. How am I going to find the gradient? Easy. The gradient comes from the gradient formula. So that means I've got to differentiate. So if I differentiate and then stick the x number into that formula, that's going to tell me what the m is. Once I've got these two pieces of information here, the point and the gradient, I can then use the y minus b equals mx minus a to get the equation. Question says you've now got to prove that that formula, y equals, okay, and I'll give you a wee head up because I'm feeling in a good mood. I'm going to tell you that your answer for the first part should be 4x minus 2. Right, so you've got to show that that answer is a tangent to this circle. How are we going to do that? We're going to take the 4x minus 2 and we're going to substitute it in here for the y coordinates. Okay, so we're going to end up with x squared plus not y squared. We're going to have a 4x minus 2 squared minus a 12x minus a 10, and we're going to have a 4x minus 2, and so on and so on and so on. If I remove all the brackets and tidy it all up, I should get to a situation where I've got two brackets equal to 0. And what we're hoping is that these two brackets are the same. Why are we hoping that they're the same? Because if they're the same, we'll only get one x number, so the line only cuts it in one place. Okay, but you've got loads of algebra to do to reach there. Question 5. Okay, so we've defined a point C that splits AB in the ratio 2 to 1. So 2 here, 1 there. So we're trying to find C. So the little formula we're going to use is C equals, and then remember how we do that, the 2 multiplies the B, so equals 2B, the 1 multiplies the A, plus A, divided by these two numbers added up, divided by 3. So I know what little b is, that's just that point turned into a vector. I know what little a is, that's just that point turned into a vector. If I plug them into this formula, then I'm going to be able to work out what C is. Remember, big C, there's a coordinate, so write it as a coordinate. The question says, now you've got a point D, excuse me, and this time C divides DE in the ratio 3 to 1. So another diagram, C divides DE in the ratio 3 to 1. Okay, so it's very, very similar to the first one. Okay, so again that will generate a wee formula for you, which says C is equal to 3 times E plus 1 times D divided by 3 add 1, 4. Okay, problem this time is, I know what D is, question tells me that. I know what C is, I've just worked that out, but I don't know what E is. Okay, so the first stage you're going to have to do is, looking at this formula here, is you're going to have to change that subject to what E equals. Okay, how are we going to do that? Well, we're going to get the 4 over to that side, then we're going to get the D over to that side, and then we're going to get the 3 over to that side, and we'll get a little formula involving E. Once I've got a little formula involving E, I can then put what the C is, and I know that, what the D is, into the formula, and then I can work out the coordinates of E. Okay, so it's very similar to the first one, you just got to rearrange the formula first of all. This question says calculate the size of angle B, C and E. So a wee diagram for that is B, C and E, and we're trying to work out that angle in there, theta. So for us to work out that angle in there, I need to know this vector which is going away from the angle and this vector which is going away. Let's call this vector U, this vector V. Then I'm going to have cos theta is U dot V divided by the length of U times the length of V. Okay, you need to work out the U and the V in the first place. I'll move that to the side a wee bit. Okay, we know that U is equal to C to B. So we can work that out, and we know that V is equal to C to E. So we can work that out. So once we've got these two vectors, we can use them in this formula to get what theta is. Okay. Now just to make sure, I'm going to tell you again, because I'm in a good mood, that for the C part, you should have found the C answer earlier on to be 6, 3, 5. Okay, so you can check back to make sure you got that for C. And for E, you should have found that to be 5, 5, 3. Okay, so you'll be able to check for your first two parts of the question to see if you got them. So you can use those numbers along with the B coordinate, which is given in the question, to work out theta. Okay, looked like a wee short question, but that is actually a bit of a monster. Right guys, hopefully that's helped you do some of it.